You're probably familiar with the idea that the speed of light is the ultimate speed limit in the universe. Nothing can go faster than it. But here's the thing that people don't grasp, and I mean really grasp, is why that matters. It's not just a rule. It's not like someone sat down and said, okay, let's make a rule that nothing can go faster than light. No, it comes from something much deeper. It comes from the very fabric of space and time themselves. And what happens when you approach that speed is something that seems like science fiction, but it's absolutely real. It's called time dilation. And it's going to be the key to understanding why our hypothetical aliens are stuck. Now let me describe this in a way that makes sense. Imagine you have a clock, not your wristwatch, but imagine a perfect clock. A clock that bounces light back and forth. The light goes out, bounces off a mirror, and comes back. Every time it comes back, it ticks. It ticks once. That's your unit of time. You understand? Simple. Now, you've got this clock, and I've got an identical clock. But here's the setup. You're stationary, and I'm on a spaceship moving very, very fast. Let's say I'm moving at some significant fraction of the speed of light. Let's say 90%. What do you think happens to my clock? From your perspective, here's what you observe. My clock is moving, and the light in my clock has to go out and come back while the whole thing is zooming away from you. So from your reference frame, the light has to travel a slightly longer distance because I'm moving. It takes more time for the light to make its journey. Therefore, you observe that my clock is ticking more slowly than yours. My clock is running slow. Now, from my perspective, I feel completely normal. I don't feel like I'm moving slowly. My clock appears to tick at its normal rate to me. But you're watching my clock, and it's definitely ticking slower. This is not an illusion. This is not because the clock is broken. This is real. This is a fundamental property of time itself. Time actually does move more slowly for someone who is in motion relative to you. And the faster you go, the more pronounced this effect becomes. We can measure this. We did measure this. In 1971, two physicists, Hale and Ketting, put atomic clocks on airplanes flying in opposite directions around the Earth. The clocks that flew on the airplanes actually aged slightly less than the clock that stayed on the ground. We're talking microseconds, tiny amounts, but it was real. Time was literally running slower for the moving clocks. Now, the reason you don't notice this in everyday life is because you never go fast enough. You could drive in a car at 100 miles an hour, and your clock would be running at the same rate as everyone else's clock on Earth. The effect only becomes noticeable when you're going a significant fraction of the speed of light. And the speed of light is 186,000 meters per second. Let that sink in. 186,000 meters per second. There's nothing that moves that fast that we can currently build. The fastest rockets we have right now are moving at perhaps 30,000 miles per hour. That's nowhere close. But let's think about what happens if we could build a spaceship that could travel at 95% the speed of light. At 95%. Let's say we want to go to a star that's 10 light years away. From Earth's perspective, from someone standing here watching you leave, the trip would take about 10 years. You'd get there, you'd look around, and 10 years would have passed on Earth. But here's where it gets interesting. For you, aboard the spaceship, traveling at that speed, time is running more slowly. Let me give you the actual numbers. At 95% the speed of light, your clock is running at only about 1/3 the rate of clocks on Earth. So while 10 years pass on Earth, only about 3 years pass for you. You would have aged only 3 years while everyone on Earth aged 10 years. When you get back to Earth, you are a young person, and everyone you knew has become old. Your twin brother, if you had one, would be 7 years older than you. This is not science fiction. This is called the twin paradox, and it's perfectly described by Einstein's theory of special relativity. It's one of the most mind-bending but completely real consequences of the fact that we live in a universe where time is not absolute. Time is relative. It depends on how fast you're moving. Now here's where it gets really interesting, and here's where we can start to see why aliens would be stuck. Let me ask you a question. If you left Earth on this spaceship traveling at 95% the speed of light, and you wanted to send a message back to Earth telling them that you'd arrived safely, what would happen? Well, light travels at, by definition, the speed of light. The signal you send would take the same amount of time to come back as it took for you to travel there. You'd arrive after 10 years from Earth's perspective, and then your signal would take another 10 years to get back. 20 years total. You're trying to communicate with people who are now old, who probably don't care anymore. You're completely isolated. But wait, it's even worse than that. Imagine Earth wants to send you a course correction. They realize after you've been traveling for a few years that you should change direction, or they made a mistake in the coordinates. They send a signal at the speed of light trying to catch up with you. But you're traveling at 95% the speed of light. You're moving almost as fast as the signal they're sending. Eventually, if they wait too long, you'll be moving faster away from them than the signal can catch up. From their perspective, they're watching your spaceship pull away, and the signal from Earth just can't catch you anymore. It falls behind. You've left the sphere of causality. You're on your own. That's the key insight. That's why interstellar travel is so fundamentally difficult. Not because of engineering, not because we can't build the rockets, but because the universe itself, the fundamental laws of physics, have structured things in such a way that if you want to reach another star system in a reasonable amount of time, you have to travel very fast. And when you travel very fast, time behaves differently. Communication breaks down. You become isolated. You become, in a sense, stuck in your own pocket of time. Let me make this more concrete because I want you to really understand what we're talking about here. Our galaxy, the Milky Way, is about 100,000 light years across. Proxima Centauri, the closest star to us, is just over 4 light years away. The nearest large galaxy, the Andromeda Galaxy, is 2 million light years away. These are immense distances. At our current technology, traveling at anything approaching significant fractions of the speed of light is completely impossible. We don't have the energy, we don't have the propulsion systems. But let's pretend we could somehow develop that technology. Let's say we develop some kind of advanced propulsion system, maybe antimatter rockets or something we haven't even thought of yet. And we can accelerate to, let's say, 20% of the speed of light. That's still incredibly fast. That's about 40 billion miles an hour, roughly. At 20% the speed of light, you could reach Proxima Centauri in about 20 years from Earth's perspective. For you aboard the spaceship, time dilation is less dramatic at this lower speed, but there's still an effect. You'd age only about 19.5 years for every 20 years that pass on Earth. So the effect is small at these speeds, but it's there. But what if a civilization, let's call them the aliens in question, was advanced enough to build ships that could reach 90% the speed of light, or 95, or 99? Let's really push it. Let's imagine the Arcturans for the sake of argument. They're living on a planet around a star that's 36 light years away. They're incredibly advanced. They decide, you know what? Let's go to Earth. Let's visit that little blue planet. They build a spaceship that can travel at 99% the speed of light. That's unimaginably fast, unimaginably powerful, but theoretically possible. According to Einstein's equations, at 99% the speed of light, time dilation becomes extreme. For every year that passes on Earth, only about 2 months pass aboard the spaceship. The crew aboard that ship could make the entire trip to Earth, 36 light years, and only experience about 6 years of travel time. From Earth's perspective, 36 years have gone by. But the Arcturans aboard the ship, they've only aged 6 years. They arrive here, and they've traveled through 3.5 decades of Earth history in what feels like a few years to them. Now, here's what makes this relevant. When they arrive, they can't send a message back to Arcturian command saying, "Hey, we made it." Because by the time that message travels back to Arcturians, another 36 years, More than 70 years will have passed on Arcturians since they left. Everyone they knew will be dead. Their orders back home will be completely irrelevant. They can't follow up instructions. They can't ask for more supplies. They can't coordinate with anything back home. In a very real sense, they're alone in the universe. They're stuck in their own reference frame, unable to maintain any kind of real-time connection with their home world. And this is where the Fermi paradox comes in. You know, the Fermi paradox, it's the question. If the universe is so big and there are so many stars and statistically there should be lots of aliens out there, where are they? Well, the answer might be that the laws of physics themselves make it practically impossible for interstellar civilizations to maintain any kind of connected empire or network. Every civilization is essentially isolated. Every space probe that leaves is on its own. And when you really think about it, that's a profound constraint. That's the universe saying no. You can have a single star system, or you can travel to other star systems, but you can't do both easily. You have to choose. Let me approach this from another angle to make sure you really see it. Suppose intelligent life is common. Suppose in our galaxy alone there are thousands of civilizations. They all want to explore. They all want to expand. They all want to make contact. But the problem is this. The distances are so vast that even at relativistic speeds approaching the speed of light, it takes decades or centuries to reach nearby star systems. And if you go fast enough to make the trip feel quick to you, you've isolated yourself from home. You can't go back. You can't maintain communication. You've essentially become a separate branch of your own civilization, drifting alone through space. Now, some people ask me, well, what about wormholes? What about warp drives? What about faster-than-light travel? And I'll tell you these are mathematically possible in Einstein's general relativity. They're not forbidden by the equations. But, and this is a big but, they require forms of energy and matter that we've never observed and probably don't exist. A wormhole, for instance, would require what's called exotic matter with negative energy density to keep it from collapsing. We've never seen such a thing. A warp drive would require the ability to literally bend space-time, to create a bubble where space contracts in front of you and expands behind you. It's an interesting idea, but it would require energies on the order of the energy of the universe itself. It's not practical. It's not something you can build. So we're left with the universe as it actually is, governed by Einstein's relativity, with light speed as the ultimate speed limit and time dilation as a fundamental consequence. These aren't arbitrary rules. They're not limitations imposed by something we don't understand. They're intrinsic to the structure of space-time itself. Let me describe one more scenario that really highlights the problem. Imagine a civilization on a planet around a star 50 light years away. They're at least as advanced as we are today, maybe much more so. They develop a probe, a robotic explorer that they send toward us. They build it to travel at 50% the speed of light. That's still incredibly fast, but it's more achievable than 99%. The trip takes 100 red years from Earth's perspective. The robot arrives in the year 2124, roughly. Now, the robot's creators programmed it with all the knowledge they had in 1975. 100 years of knowledge on their home world has gone by while the robot was in transit, but the robot doesn't know any of it. They can't give it updated instructions because any signal they send now will take another 50 years to reach Earth, and the robot is already here. This robot is in a sense an ambassador from Earth's past. It arrives and what it explores. It transmits what it discovers back home, but there's a delay. It can't conduct a real-time conversation. It can't respond to Earthside questions in real time. It's operating on a 50-year round-trip communication delay. Every question Earth asks takes 100 years to answer. It's like trying to have a conversation with someone from the past. This is what I mean when I say that time itself is a fundamental barrier to interstellar civilization. It's not that we haven't invented the right engines. It's that the laws of physics are saying something very specific about the structure of the universe. They're saying you can have locality or you can have connection, but maintaining both across interstellar distances is prohibitively difficult. Now you might ask, well, what if there are aliens who have solved this problem? What if they found a way? And I say, sure, maybe they have. Maybe there's physics we don't understand. Maybe there's a way to bypass these limitations that we can't even conceive of right now. I'd be delighted to be wrong about this, but here's the thing, we have no evidence for that. And in science, we can't assume something exists just because we can't prove it doesn't. We have to go with what we know. And what we know is that Einstein's relativity, as far as we can tell, is correct. The speed of light is constant. Time dilation is real. And these things make interstellar travel inherently, fundamentally difficult. This is why I often say to people like, if you're looking for aliens, don't expect them to have visited us. Not because they're not out there, but because the universe is much larger and much more isolating than our intuitions would suggest. The vast distances combined with the relativistic effects of high-speed travel mean that contact between civilizations would be extraordinarily rare and extraordinarily slow. You wouldn't have a Star Trek situation where spaceships are zipping back and forth between star systems. You'd have isolated pockets of civilization, each aware of the others, only through signals that take decades or centuries to arrive. And here's maybe the most interesting part. This same limitation applies to any civilization trying to explore. Let's say the aliens are incredibly advanced. They figured out how to build ships that can coast along at 90% the speed of light indefinitely. They've solved all the engineering problems. They still can't escape the fundamental constraint that time dilation imposes. If they want to explore the galaxy and eventually return home, they face a choice. They can either move slowly through the galaxy, taking thousands of years to cross it, aging slowly the whole time relative to home, or they can move quickly, age very little, but become completely isolated from home. They can't maintain a home base and a growing exploration network simultaneously, not at any meaningful level. Some might imagine a scenario where aliens have become what's called post-biological. They've uploaded their minds into computers. They don't age anymore. They can wait indefinitely. Even for them, there's a problem. The speed of light constraint means that causality itself becomes a problem. You can't have a real-time command structure. You can't have coordinated actions across interstellar distances. Every independent colony becomes effectively autonomous. They might start out as part of the same civilization, but over time, they drift apart. They develop different cultures, different objectives, different ideas. It's almost as if the universe itself is designed to prevent civilizations from expanding indefinitely. I think this is a profound insight. It's why the Fermi paradox might actually have a simple answer. Why don't we see aliens everywhere? Why haven't they colonized the galaxy? Because the galaxy is so big and the rules of physics are so constraining that any civilization is essentially limited to its local neighborhood. They can't expand much beyond a few dozen light years without losing connection to home. They can't maintain a galactic empire, and isolated pockets of civilization separated by light years and decades of communication delay simply won't have much contact with each other. Now, what about us? Well, we're sitting here on Earth with the same problem. If we wanted to send a probe to another star system, we'd have to accept that it's on its own. We can't control it. We can't help it if it runs into a problem. It can send us information, but only after years or decades of travel time. And if we wanted to send humans to another star, that's even more difficult. Even in optimistic scenarios where we somehow develop the technology to accelerate to 50 or 60% the speed of light, which is probably 1,000 years away, if ever, we'd be looking at journeys of decades or centuries. The people aboard would leave Earth and reach another world where decades or centuries had passed for everyone back home. They couldn't really come back. They couldn't maintain contact. They'd be colonists of the highest order, completely separated from their home world. This is why some scientists speculate about generation ships, spacecraft where people would live out entire lifespans and their descendants generations later would finally reach another star. You'd have a society aboard the ship isolated for centuries, aware that Earth was generations in their past. It's possible. It's consistent with physics, but it's also profoundly lonely. It's the kind of isolation that would fundamentally shape any culture that attempted it. So when I think about this question, why aren't aliens here, I think about these constraints. I think about the fact that the universe, despite being large and probably full of life, is structured in such a way that civilizations are essentially isolated from each other. Each one is stuck in its own reference frame, moving through space and time in its own bubble, unable to easily connect with distant others. The speed of light is this fundamental boundary that you can approach but never cross. And time, that thing we all take for granted as flowing at the same rate for everyone, is actually flexible. It changes depending on how fast you're moving. The universe, in a way, has arranged things so that advanced civilizations wouldn't be running into each other constantly. They'd be isolated, separated by light years and time delays and relativistic effects. And any civilization that tried to expand too aggressively, moving fast through space, would find itself cut off from home, unable to maintain contact with where it came from. It's a built-in isolation mechanism. It's not something someone designed, but it's there anyway, written into the laws of physics. This is the reality check. This is why aliens are stuck in time. Not because they can't build good spaceships, not because they're not intelligent enough, but because the universe itself, because the fundamental laws that govern space-time have structured things so that rapid transit across interstellar distances necessarily creates temporal isolation. You can't have it both ways. You can't quickly reach other star systems and remain in communication with home. The choice is built into the equations. And I find this beautiful, actually. I find it beautiful that the universe has these inherent limitations. It means that if there are other civilizations out there, they're not going to suddenly show up and colonize Earth. The physics won't allow it. They'd have to move slowly, or they'd have to accept isolation. And given those constraints, the galaxy probably looks much emptier than we'd intuitively expect. Each pocket of intelligence is separated from the others by time and distance in ways that make contact difficult, rare, and slow. So that's what I mean when I say that aliens are stuck in time. They're not trapped in some alien science fiction prison. They're bounded by the laws of physics themselves. They're constrained by relativity. And if they're trying to explore or expand, they have to accept that expansion means isolation. They have to accept that time will behave differently for them than it does for those back home. They have to accept that they're in a real sense moving through time and space into a future that home can't reach for years or decades or centuries. The universe is big, it's beautiful, and it's structured in a way that keeps civilizations apart more than it brings them together. And understanding that, understanding time dilation, understanding relativity, understanding these fundamental constraints gives us a much clearer picture of what the cosmos is actually like, as opposed to what our imaginations suggest it should be like. That's the interstellar reality.